Hello everyone. Today we're going to talk about a crucial topic in the world of technology, hardware. But what exactly is hardware? Hardware refers to all the physical parts of a computer system, meaning everything you can touch. Without hardware, we simply couldn't use software or digital devices in our daily lives. Think about the computer you use for work or your mobile phone. All of that is hardware. And in this video, we're going to discover how it influences our lives. It helps us with communication, education, work, entertainment, and even health. As you can see, it's not just something we use for playing games or sending messages. Our daily lives literally depend on hardware as it's everywhere from computers to medical devices. Now let's talk about one of the most important parts, microprocessors. A microprocessor is like the brain of the computer. It's an integrated circuit responsible for performing all the mathematical and logical operations necessary for the machine to function. And be careful because this generates a lot of heat, as this is why we always see fans and cooling systems keeping the microprocessors cool. Processors have evolved drastically over time, from the Intel 4004 to the 1971 to advanced processors like the Apple M1 in 2020. Looking at this timeline, we can see the generation of processors have increased in power and efficiency. And it's not just the Intel that has been innovated, we also have significant players like AMD Ryzen and the recent Apple M1, which have revolutionized the industry in recent years. And this is just the beginning. There's much more to explore about hardware, so stay tuned as we have several interesting topics left to cover. Let's talk about another crucial component in hardware, storage memory. We all use devices that store information, but what other types of memory exist? There are two types of HDD and SSD of traditional hard drives. They use spinning magnetic disk and mechanical read and write heads. This type of memory is quite common in older desktops and computers and offer larger storage but at lower prices. On the other hand, we have SSDs or solid state drives. These use non-flash memory, meaning they have no moving parts. This is what makes SSDs much faster and much more resistant to shocks or drops. They're ideal for enhancing the performance of any device from laptops to gaming consoles. But we don't stop there, because there are also more advanced technologies like persistent memory or PMEN. This memory combines the best of both worlds, the speed of RAM and the ability to store data non-volatile, meaning data isn't lost when the device is powered off. Additionally, there are emerging technologies like the NVMe protocol, which is specifically designed for SSDs. Further, optimizing data transfer speeds. In short, with NVMe and SSDs, you can move data faster than ever, making computers more agile and responsive in milliseconds. Now it's time for another essential component in the world of hardware, graphics cards, also known as GPUs. But what exactly are graphic cards? Essentially, a GPU is specialized components for processing and rendering graphics. Its main task is to handle everything we see on screen, such as images, videos, and animations. GPUs are also very useful for complex mathematical calculations, which many people don't realize. And moreover, their use isn't limited to video games or visual effects. In fact, in the field of civil engineering, graphics cards play a key role in various tasks. For example, they're used to design plans and structures in specialized software like AutoCAD or Revit. They also are vital for structural simulations where engineers can visualize stresses and deformations in material, helping to anticipate potential failures or adjustments in a structure. Not only that, but they're also employed in terrain modeling and analysis using the positional data. Thanks to graphics cards, it is possible to create realistic three-dimensional models that helps engineers and architects visualize how the finished project will look before bringing it to life. The world of graphics cards has undergone incredible evolution over the past few decades. Let's take a look at how these GPUs have changed over the years and how much each advancement has made a difference in technology. Starting in 1981, with the first standard graphics cards, the IBM CGA, the Colored Graphics Adapter. Released by IBM for personal computers, it allowed a palette of 16 colors and resolutions of 320 by 200. While very basic compared to today's standards, it marked the beginning of graphic cards in PCs. Then in 1995, the 3D FX Voodoo arrived, revolutionizing the gaming world as the first dedicated 3D graphics card. It elevated video games to a new level, enabling real-time rendering with texture smoothing significantly improving visual quality. Forwarding to 1999, when Nvidia launched the GeForce 256, considered to be the first true GPU, this card integrated transformations and lightning calculations directly into the hardware, offloading tasks from the CPU. This increased graphical performance and allowed for much more complex 3D environments. However, GPUs are not for graphics, not only just for graphics. In 2006, Nvidia introduced CUDA, which enabled graphics cards to be used far beyond graphics. Potential calculations and parallel calculations utilize an AI and scientific simulations and even data analysis. And finally, in 2018, NVIDIA introduced something that would change graphics forever, real-time ray tracing with its RTX 20 series. This technology was creating incredibly realistic shadows and reflections, what was only possible in CGI films. Each of these advancements not only enhanced visual quality but also expanded the use of GPUs across multiple industries. From entertainment to science, graphics cards have had a tremendous impact. Now we turn to the motherboard, also known as the mainboard. This is one of the most important components of any computer. The motherboard is the main board inside the computer containing all the electronic circuits that allow the systems to function. It is where the processor, memory, and main connections are connected. We could say it's the heart of the system as it connects all the computer's components, for without the motherboard, there would be no way for the other elements to work together. In fact, this type of technology has been present since the dawn of computing and has evolved with every advancement. Today's motherboards not only connect components, but also control all elements of the system. That's why choosing a good motherboard is crucial when building or upgrading a computer, as it must be compatible with all other components such as all the processor, the memory, and the graphics cards. Ultimately, it serves as a control center of the computer, and its importance cannot be overstated. Without the motherboard, we wouldn't have a functional system. Now let's talk about the key concept that allows all computer components to work together: communication interfaces. Communication interface enables two or more components to share information and function in a coordinated manner. Without these interfaces, it would be impossible for components to communicate with each other. Most of this information exchange occurs in the form of bits. Bits, the smallest unit of data, are transported through dedicated cables known as buses. These buses are essential for the proper functioning of the computer as they allow components like the processor, the memory, and the graphics card to send and receive data in real time. We can think of buses as the data highways within the computer, facilitating the flow of information between all the parts of the system. Without them, the system simply wouldn't operate. When we discuss communication interfaces, we refer to the fundamental connection that allows each component to function harmoniously with the others. Now we see the timeline of the communication interfaces. Now let's dive into the three of the most relevant: USB, Thunderbolts, and HDMI. Let's start with USB. The evolution of USB has been impressive, from its first version in 1996 to the current USB 4.0. We will discuss its key milestone and how each version has improved speed and functionality. HDMI has revolutionized the way we connect video and audio devices, allowing for unprecedented image and sound quality. Thunderbolt, an interface that has taken data transfer to a new level, especially with its most recent versions that combine speed and versatility. Now let's talk about hardware peripherals. What exactly are they? Peripherals are hardware devices that connect to a computer's motherboard and act as an interface between the user and the machine. Their main function is to meet needs such as inputting, outputting, or storing information. Peripherals allow us to interact effectively with a computer, whether by entering data, viewing results, or saving information. Some common examples of peripherals include keyboards and mice for data input, monitors for display, and printers for document output. We can also consider devices like external hard drives and flash drives as storage peripherals, as they allow us to save and transfer data. So peripherals are essential for the full functionality of a computer as they extend and enhance our capabilities to interact with the system.